Hi, I'm Nathaniel Deal, and this is the AmmoCounter V1 IR beam detector setup. So in this video, we're going to go over how to set up a circuit, how to connect it to an Arduino, and how to add an internal IR beam to your blaster. So without further ado, let's get to it. Okay, so for this section, you're going to need the following parts. The IR beam detector and emitter that I got from SparkFun, a 330 ohm resistor, a 10K resistor, a breadboard, some male or female jumper wires depending on how your Arduino is set up, the Arduino, and an AmmoCounter V1 kit assembled. So the first thing we're going to do is set up the breadboard. I always prototype with an Arduino Uno and a breadboard combo for two reasons. One, because it's stationary. I don't have to worry about moving things around. And two, it's got some built-in features that the smaller ones don't, that may help you get past power issues and stop you from burning it out faster. All right, so the first thing we need to do is set up the power. I've jumped the VCC and the ground to the breadboard here. There's also a couple of jumpers here to get it to the other side. So now both rails have positive and negative power. And the second thing we're going to do is we're going to put the IR LEDs into the breadboard, making sure the LEDs are facing each other because that is how the beam is set up. All right, so there are two LEDs here. One has yellow and one has a red dot. The yellow dot is the emitter and the red dot is the receiver. So the first thing we're going to do is add the red dot and the yellow dot in here. And then I'm going to put the other guy over here so they can see each other. There are two bumps on either side, and that kind of dictates which way the beam is going. So if I put my hand between here, it should be able to break the beam. All right, so I'm going to connect the negative leads of the LED to the negative strip here. So if you pull the LED out, you can see one's longer. When it comes to LEDs, the longer one is always the positive. So I'm going to put this guy back in here. I've noted that this is the negative. So I'm going to jump that over to negative. And then pull this guy out. And it looks like the negative's on the opposite side. So I'm going to jump him over to negative. And there we go. All right, the second thing is that we need to add some resistors. All LEDs need resistors. If not, they would burn out. So the emitter needs a 330 ohm resistor, orange, brown, I believe. And what I'm going to do is I'm just going to jump the positive lead into the positive, sorry, that's in the wrong place, into the positive rail here. So positive lead to the positive rail with the 330 on the emitter. Remember that has the yellow dot. And then for the receiver, I'm going to use the 10K resistor, and I'm going to jump that positive into the positive rail. There we go. It's a little in the way. All right, so that will give us the power we need for the emitter and the detector. And in order to read the detector and the resistance coming off of it, we need another wire that we're going to be putting in between the positive and A2. There we go. Now what this is going to do is that when the resistance between the two beams changes, you're going to get that voltage drop using this voltage divider that we've set up on the A2 pin. And we'll use the Arduino to tell if this has been broken or not broken. All right, so that's it for the first step. Now we're going to test the beam. So just a little bit about voltage dividers. They're very common with Arduino sensors and are very handy when you want to detect changes through an analog pin. The Arduino will monitor the voltage on the LED to detect a change, and when the voltage changes, the counter will count down. You can't see the infrared light on one of these IR beams, so you could using a camera with a UV filter, but there's another way to do it. We can basically plug in our Arduino and then detect the change using the serial monitor. So let's plug the Arduino in and see what's happening. Okay, now let's go to the computer and open up the Arduino IDE. Double click on the AmmoCounter sketch if it's not already open. If you don't have it, it's available on AmmoCounter.com. In the code, you'll see a section labeled Monitor IR Beam. This is the code that watches the voltage change and counts down if a dart is detected. The bottom of this section contains a piece of code that outputs the digital reading from the IR beam setup. Upload the code to your Arduino, make sure you have the right board and port selected, and then open the serial monitor on the top of the Arduino IDE. Now move your finger between the LEDs and you should see some numbers display in your serial monitor. Okay, so how it works. The IR beam detector divider steadily gives you a low voltage readout, somewhere between 50 and 60 on the scale. When you break the beam, the resistance is lowered and the voltage goes up to about 250 depending on the setup. The range varies depending on your dart speed, so if your counter is having trouble keeping up, you could change these values to make it more accurate. I also want to point out that ambient light will affect your beam, so testing in a real use case is ideal. You want to kind of keep that ambient light down so that you get the best reading as possible. Okay, so now we're going to go a little bit further and test this using the AmmoCounter V1. So I've installed the kit. This is assembled, available on AmmoCounter.com. The wiring is set up. If you have questions about the wiring, check out the overview video that I did on my channel. So just to double check to make sure this is working, you should just be able to break this beam and see the dart counter count down. So everything looks good. The next step, I'll show you how to install this into a Nerf blaster. Okay, so for this section, you're going to need the following parts. You're going to need a Nerf gun. Any Nerf blaster will do that you want to integrate with. I'm going to use the Yellow Raven for this. You're also going to need the IR beam emitter and detector setup we did earlier. 12 inches of wire. 3, you'll need a red, a black, and I'm using green for the signal. And then you're going to need 3 jumper wires to connect to the Arduino. Preferably, these should be the same color. In addition to these parts, you're going to need the following tools. You're going to need a screwdriver to take apart the blaster. You're going to need some wire strippers. So electrical tape, which I just ran out of, so we're going to see how that works. A drill. I'm going to use a Dremel, preferably with a 1/8 inch bit. A little bit bigger could work too, but at least 1/8 inch. And a soldering iron, which is over here that I can't pull into view. And some heat shrink to put around the connections. So let's wire up the detector. Okay, so now we'll need to reconstruct the IR beam circuit we made earlier. First, we're going to cut 2 inches of wire and solder that to the negative terminal of the IR beam. It doesn't matter which one. Let me just strip this. Grab one of these beams. I'm going to grab the other one. And remember, the negative one is the shorter one. So let's wire that up. Okay. So if you don't have a soldering iron, electrical tape should do here, or you could use a small wiring nut. So we take the other end of the small wire and we wire that to the other beam. Remember, the short one is the negative, so I'm going to bend it out. Connect this. All right, there we go. So now we have both negatives connected. Now I'm going to strip out the end of the black wire, and I'm going to connect it to that same connection here so that we can connect him to the Arduino. All right, there we go. Feel free to add shrink wrap in between these. I didn't have time, so I'm just kind of going through this pretty fast. So what you can see is that we have both negative leads connected together, and then the longer piece that we can connect to the Arduino. The second thing you want to do is to grab the red wire and then cut about 2 inches of that off, and then strip the ends off like we did before. A little more on this one. A little more here. And then we're going to connect this one to the 330 ohm resistor. So I'm going to grab that out of my circuit and put those together. There we go. And now we're going to take the remaining end of the 330 resistor and we're going to connect it to the emitter. Remember, the emitter is the one with the yellow dot. So connect that here. There we go. And it's very important to add some of the shrink wrapping, but I'm not in this case because of time. So take your clippers and clip off the extra wire here. The extra ends, I'm sorry. And a little bit here. All right, so that way we have our 330 ohm resistor going into our an emitter. And then the next thing we want to do is we want to solder one end of the 10K resistor to the positive terminal on the IR detector with the red dot. So red dot, positive detector terminal. Wrap that around a couple times. So we got that guy. Cut him off at the end here. Cut the little lead off. All right, looking good. All right, so now we have our resistor on our red LED and our resistor on our yellow LED. And the last thing we want to do is we want to solder the two resistors together. Like so. We're going to make a loop. And this will wrap around our barrel. So I'm going to solder this. Wrap them together. And then we're going to connect this end to the rest of the red wire, which technically we didn't have to take off, but whatever. Here we go. So you want to wrap all these connections. It's very important to wrap these connections with some kind of insulator or tape. But that is our basic circuit for the power. The last thing we want to do is we want to add our green wire, which is going to send the signal. And if you remember, the signal wire goes right between the positive and the positive terminal and the 10K resistor. A little confused myself here. All right, so that's the hard part, and I kind of sped through it because I just wanted to get it done in one take. But so there's your three wires. The next thing we're going to do is we're going to connect these to our jumper wires. So let's cut the ends off of these guys so that we can connect it to the Arduino. And there you have it. The circuit has been replicated and ready for installation. Make sure you tape those up. All right, so now we're going to open up the blaster shell. So I'm not going to go too much in depth on how to open up one of these blasters. There are tons of videos out there for whichever blaster you probably have. I decided to use this Nerf Raven for this demo, and I've already removed the screws. So we're going to take the blaster top off, and then we're going to remove the barrel, which is pretty easy. Just pull it out. We won't need the rest of this blaster. But before we take this out, we kind of want to make sure that we don't hit anything, any internals that are happening inside of here. This blaster was previously modified Now that I think about it, has an automatic pusher for the Raven, and I removed the spring that was in here. But you just want to make sure you can identify a spot that you can add the IR beam without interfering or anything. So it looks like right about here. So I'm going to make a little mark, maybe around this area here. Okay, so you won't need the rest of this blaster. Just go ahead and push it out of the way. All right, so for the next part, we're going to insert the IR beam into this barrel. All right, so we're going to take this barrel and add the IR beam. The first thing we need to do is drill a hole so that the beam can shoot through the barrel, and then when the dart passes through, it will break the barrel. All right, so this part's a little tricky. We need to drill the hole in the location we marked on the barrel, but we want to get it in one straight shot. So eyeball the center of the barrel and then drill straight through. If you get it misaligned, it's okay. You can just move down an inch and then try again. The extra holes won't cause a misfire or anything. So I'm gonna drill this barrel real quick. All right, there we go. Got it straight through. Yep, looks good. All right, so grab your IR detector, and I cleaned this one up a little bit. It was a little shoddy, but swear, let me get all this stuff out of here. I swear it's not that hard to do, but you basically want to make sure that the two bumps are facing each other. And then you want to position these so that they go through the barrel and they can see each other. So, sort of like that. Then you want to take a piece of tape or a zip tie in this case and zip tie these guys down. So I'm going to lay him down like this. Put the tie on. Get pretty close. And then get my beam inside. Go. And I usually use some electrical tape for this, but like I said, I am out, which is kind of causing an issue in every way possible. So anyway, these guys in place and kind of bend them, form them around. Tape would be great right now. Let's see if I can find something else to kind of sit on that. And then that's it. Next, we're going to test the beam. Okay, so for the final step, we're going to connect the IR beam that we just made back to the Arduino setup that we had earlier. I did add a piece of blue painter's tape here so that these would kind of stick in the holes. All right, so we take the red wire, put it into the red rail, the black wire into the negative rail, and the green wire is going to go into the same strip as the white wire that I had earlier that goes to the A2. All right, so we're going to plug it in, and then if everything's wired up all right, when we drop a dart through, it should count down. So 17, 16, 15, and one more, 14. So everything is working okay, and this internal barrel is ready to be reinstalled back into the Raven that I took it out of. You're just gonna have to kind of take the smaller Arduino and rewire everything back up and put it inside along with the ammo counter. All right, so a couple notes before we end the video. You can install this externally into one of the barrels that Nerf makes that connects onto the end so that you don't have to take apart your blaster, which is totally fine. You could even 3D print a custom end that holds the IR beams. I did make one. This is the a muzzle that connects to the end of one of these barrels. It comes in two pieces. This piece holds the IR beam, and then some notches here to hold all the wiring, and then it connects back in. The wiring flows out through here and then connects to the Arduino internally. So this is another option. This is available for sale on AmmoCounter.com if you're interested in it. And I can install that for you too. So yeah, thanks for watching this IR beam setup. If you have any questions, please visit AmmoCounter.com and go to the forum. And again, thanks for watching, and please subscribe and like.